Hey there, fellow knowledge seeker. You submitted some seriously interesting research on robots and AI.
Mm.
A preprint paper called Data Scaling Laws in Imitation Learning for Robotic Manipulation.
Yeah.
It sounds kind of dense, but trust me, it's super cool.
Oh, yeah, for sure.
We're diving deep today into how robots can learn just by watching humans and what
Interesting.
it takes to make these robotic learners true generalists.
Like jack of all trades robot.
Exactly. You specifically mentioned being curious about how this type of robot learning compares to all the buzz around large language models in AI.
Right.
Are there any parallels?
Absolutely. In AI, we often see these things called scaling laws.
Okay.
Basically, the more data you feed an AI model, the better it performs.
Uh-huh.
This paper explores whether the same thing holds true when robots are learning physical tasks,
Mm.
like pouring a glass of water or organizing your desk.
So it's more than just dumping a ton of data into a robot's brain.
Exactly. This research isn't about quantity, it's about quality. The paper focuses on what kind of data matters most
Got it.
and how to collect that data efficiently.
So how did they figure that out?
Well, think about it like this.
Okay.
If you were teaching someone to cook,
Uh-huh.
would you have them watch you make the same recipe 100 times?
Right.
Or would you expose them to a variety of different dishes?
Variety makes sense, I guess. You
Right.
want them to learn the techniques, not just memorize one recipe.
Exactly. And that's what this research dives into.
Okay.
Two key types of generalization that are essential for robots working in the real world.
And those are?
Object generalization and environment generalization.
Okay, let's unpack those.
Sure.
What exactly do they mean?
Well, object generalization means a robot can handle different objects within the same category.
Okay.
For example, if you teach a robot to pour water from a specific bottle,
Uh-huh.
can it then pour from a pitcher or even a carton?
Interesting.
Yeah.
So it's about adapting to different shapes and sizes within a category.
Precise.
Okay, what about the other one?
And then there's environment generalization.
Okay.
This means the robot can perform the same task in different settings.
Interesting.
Think about pouring that water
Yeah.
in a cluttered kitchen versus a tidy lab.
Ah, I see.
Yeah.
So the robot needs to be able to handle variations in its surroundings,
Exactly.
not just the object itself.
You got it.
So the researchers wanted to test
Yeah.
whether simply scaling up the data could improve both of these skills.
Right.
And if so, what's the most efficient way to collect that data?
Exactly.
So how did they go about testing this? Did they use simulations?
They actually went a step further. They collected over 40,000 real-world demonstrations
Wow.
using a handheld gripper that captures human movements.
Interesting.
They had people show the gripper exactly how to do things,
Okay.
like pouring water from a bottle into a mug or arranging a computer mouse on a mouse pad.
Wow. So they're basically puppeteering the robot.
Pretty much.
It sounds like a lot of work.
It was, but it was worth it.
How so?
This approach allowed them to test how well the robot could perform in various real-world environments,
Okay.
which makes their findings much more applicable to the real world.
So much more useful than a simulation.
Exactly.
Okay, so they had humans demonstrate these tasks with a handheld gripper in
Mhm.
all sorts of different environments.
Uh,
What did they find?
let's start with object generalization.
Okay.
They discovered that the more bottle types the robot trained on,
Yeah.
the better it could generalize to new, unseen bottles.
Interesting.
It's like how a chef learns to adapt a recipe to different ingredients.
Mhm.
The more experience they have, the more flexible and adaptable they become.
That makes sense.
Yeah.
So instead of just showing the robot the same water bottle over and over, they used a variety of bottles during training.
Yeah, got it.
And what else?
They discovered something else really interesting.
Oh.
They noticed that after a certain number of demonstrations with each bottle type,
Mm.
adding more didn't significantly improve the robot's performance.
So there's a sweet spot for how many examples the robot needs.
Exactly.
It's not just about mindlessly adding more data.
Right. There's a point of diminishing returns.
I see.
Think of it like creating the most effective study guide for your robot student.
Okay.
You don't need to make it 1,000 pages long.
Got it.
Just focused and diverse.
That's a great analogy.
Thanks.
So diversity in the types of bottles used for training is key?
It seems to be.
What about environment generalization?
Mhm.
Did they find similar results there?
Absolutely. They found that training the robot in a variety of real-world environments was crucial
Okay.
for helping it adapt to new ones.
So it's really about getting the robot out of the lab,
Yeah, okay.
putting it through its paces.
'Cause it's like learning to drive.
Mm-hmm.
You wouldn't just practice in an empty parking lot, would you?
Definitely not. You need to experience different roads,
Right.
traffic, maybe even some bad weather to be a good driver.
Exactly. And it's the same for robots.
Got it.
Exposing them to a range of environments during training helps them perform better
Makes sense.
in new situations.
So just like with the water bottles,
Yeah.
more diverse environments during training lead to better adaptability.
Exactly. And here's where things get really interesting.
Okay.
They found that increasing the variety of both environments, A&D objects during training, was far more important than just adding more and more demonstrations
Okay.
in the same environment with the same object.
So it's not just about rote memorization for the robot. It's
Right.
about really understanding what it's doing right.
That's a great way to put it.
Like it needs to learn the concept.
It's like the difference between memorizing facts for a test
Uh-huh.
and truly understanding a concept.
Yeah, that makes sense.
This has huge implications for robots working in unpredictable real-world settings.
So instead of being programmed for every possible scenario,
Right.
they can learn to adapt and generalize from a smaller set of diverse experiences.
Precisely. And this isn't just limited to robotics.
Really?
What's fascinating is that we're seeing this same principle at play in other areas of AI, like large language models.
Interesting.
It's not just about the volume of data. It's about the quality and diversity of that data.
So it seems like the robot is learning something more fundamental about the task itself, rather than just memorizing a specific sequence of actions.
Right. This means a robot trained to sort your recycling in a lab
Okay.
might struggle with the chaotic reality of your kitchen bin.
Yeah, I can see that.
That's why this focus on diverse data is so important.
That makes a lot of sense. So how did they apply this to their data collection strategy?
They actually came up with a pretty clever approach.
Okay.
They found that collecting data from around 32 different combinations of environments and objects was enough to train a robot
Okay.
that could generalize to new scenarios pretty successfully.
Only 32. That doesn't seem like that much,
I know, right?
considering how complex these tasks can be.
It is pretty remarkable.
Yeah.
And remember, all of this was achieved with a relatively simple handheld gripper,
Oh, right.
not a full-blown, super expensive robot.
Which means this approach could be really practical and scalable.
Exactly. This research suggests that we might not need massive, unwieldy data sets
Okay.
to train highly capable robots.
And by focusing on the quality and diversity of the data,
Yeah,
we can achieve impressive results with a more manageable approach.
precisely.
That's great news. But they didn't just focus on data collection, did they?
Right.
The paper also mentioned something about the robot's brain, or the model.
You're right. While collecting diverse data is crucial,
Uh-huh.
the robot's brain also plays a vital role.
Okay.
The researchers dug into how the size and structure of the model affected its learning.
I remember you mentioned something about scaling laws earlier. Does that
Right.
tie into this?
It does. They found that scaling up the part of the model that processes visual information did lead to better performance. The more visual information the model can process,
Uh-huh.
the better it can understand what's going on in the environment
Right.
and what it needs to do.
So it can make better decisions.
Yeah, basically.
But I think the paper also said that scaling up the part of the model that controls actions didn't have the same effect.
You've got a great memory. And that's where things get even more intriguing.
Okay.
It seems that simply making the action part of the model bigger
Yeah.
doesn't necessarily lead to better performance.
Interesting.
The researchers speculate that this is because the complexity of these tasks
Yeah.
lies more in perception than in the actions themselves.
So it's not just about making the robot's brain bigger overall.
Exactly.
It's about understanding which parts of the model
Right?
are most important for learning specific skills.
Oh, exactly. This raises some really interesting questions about how we optimize the architecture
Okay.
of a robot's brain to match the demands of the task.
So it's about working smarter, not harder.
Exactly. It's not just about making everything bigger.
Right.
It's about understanding how different parts of the model contribute
Yeah.
to overall learning and performance.
This is really making me think about all the potential applications.
Yeah.
I mean, if we can figure out how to optimize these models,
Right?
the possibilities seem endless.
Absolutely. This research opens up a whole new avenue for exploring how we design and train robot brains to be more efficient and adaptable.
So they can learn faster and better.
Exactly. It's like we're starting to understand the blueprint
Okay.
for creating truly intelligent robots.
So, based on everything we've discussed,
Yeah.
what does this all mean for the future of robot learning?
Well, it seems like the future is incredibly bright.
That's good to hear.
We're starting to crack the code on how to teach robots to be truly adaptable
Mm.
and capable in a variety of situations.
So they can really function in the real world.
Exactly. This research really highlights the importance of not just quantity, but quality when it comes to training data.
It's like sending your robot to a top tier school
Aha! I like that analogy.
instead of just cramming its head with random facts.
Exactly. And the best part is they achieved all of this
Yeah.
with a relatively simple and affordable setup.
Really?
This suggests that this type of robot learning could become much more accessible in the future.
That would be amazing. Imagine a world where robots can learn complex tasks just by watching humans.
Right.
I mean, we're talking about robots that could potentially cook, clean, or even perform surgery,
Wow.
all by observing and adapting to their
It's
surroundings.
both exciting and a little bit mind-blowing.
Yeah, it really is. It makes you wonder,
Yeah.
what are the limits here? If we can teach robots to pour water and arrange a mouse,
Right.
what's next? What kind of tasks could they learn with this type of training?
That's a fantastic question, and one that researchers are actively exploring.
I see.
This study focused on relatively simple tasks,
Mm-hmm.
but the principles they uncovered could have major implications
Okay.
for more complex robotic systems.
So there's still so much more to discover.
Absolutely.
I guess it all comes back to the question you posed at the beginning.
Yeah?
How do robots learn compared to those large language models everyone's talking about?
Right. And the answer seems to be
Yeah.
in a surprisingly similar way.
Yeah.
They both thrive on diverse, high-quality data.
Well, this has been a fascinating deep dive.
It has been, hasn't it?
I feel like I've learned so much about the cutting edge of robot learning.
I'm glad to hear that. It's a rapidly evolving field,
It really is.
and it's exciting to see the progress being made.
Yeah, for sure. Well, we'd love to hear your thoughts on all of this.
Definitely.
What are your predictions for the future of robot learning?
Mm.
What kind of robot would you like to see learning by watching humans? Let us know, and maybe we'll tackle your questions in our next deep dive.